Welcome, I'm Tim Modise. I'm inviting you to join me again as we continue with our Eskom journey. And today, as usual, we're going to start with a bit of Eskom history. And the focus is going to be on Mpumalanga operations, specifically the Hendrina Power Station. So, sit back, continue with me on this adventure as we unpack Eskom and its history. The Hendrina Power Station is situated about 40 kilometers south of Middelburg in Mpumalanga. It is one of Eskom's oldest continuously running power stations with approximately 1,000 employees. This station came into operation between June 1970 and December 1976. When it was built, it had the longest turbine haul of any Eskom power station. The last unit was commissioned in December 1976. Between 1995 and 1997, half of Hendrina's 10 units were refurbished and then boasted some of the most advanced system control technology in the world. The station's 5-in-1 control room was the first in the Southern Hemisphere. The second half of the units were refurbished between 2000 and 2003. Hendrina has had many notable achievements since its inception. In 1999, it received a Gold Award from the National Productivity Institute. The station furthermore received a special mention during the International DuPont Annual Safety Awards ceremony held in Düsseldorf, Germany on 4th November 2009. In 2010, the power station received a NOSA Safety System 5-star grading. The station was also awarded with a Blue Drop Gold Award by the Ministry of Water Affairs and Forestry in 2012 for continuous excellence in the production of potable water. The power station supplies water of excellent quality to the Hope residential area and Optimum coal mine. When words research and innovation are mentioned, our minds imagine universities and academic institutions. But these concepts do not apply only to educational institutions. Eskom takes pride of its research, testing and development program, which is the business area of their sustainability division. The Eskom Research and Innovation Center, otherwise known as ERIC, is situated in Rocheville, the south of Johannesburg. And it is at this place that you'll find just under 400 of the finest researchers, scientists, engineers, environmentalists, innovators, all under one roof. Well, to gain a better understanding of what ERIC is all about, let's talk to the people who work on this subject on a daily basis. Let's meet some of the engineers and researchers who work at this facility. And we'll also talk to Barry McCall, who's the General Manager of Research, Testing and Development within the Sustainability Division of Eskom.
This lab is called the James Watt Laboratory. So in this lab, we do a lot of research that is related to international standards. I can give you a bit of history. There's an international standard called STS that was developed by Eskom, and it's now an international standard and it's being used internationally. In essence, what we do is we research smart metering technology. And then secondly, the most important role for us is public safety, because behind me is an environmental chamber that makes sure that the meters that we roll out can operate safely in different environments. In terms of your temperature, if it's high temperature, for example, in Limpopo, the meter must still be safe and operate correctly. Meters have a 15-year life. So we do what we call accelerated life testing, which actually simulates a 10-year lifetime. to ensure that the meter can last the lifetime that it's intended for. So when Eskom buys the meters this year, it has an assurance that in 10 years' time, at least those meters will still be operating correctly. It's quite an exciting time now in the metering space, particularly with the new smart meters coming into play. With these new ones being rolled out in Midrand, you can buy a token in Durban and it will upload in your house. You don't really need to drive down to Joburg and punch in the token. So we are always at the edge of what's happening. We are always driving the new innovations that are taking place.
What we do here, we are testing different technologies. Like this one of the eutectic freeze crystallizer technology is the new emerging technology. What it does basically, it's used to recover, treat, and then recover water from the dirty stream. It can be able to treat wastewater. In this plant here, we have different stages whereby we can recover salts in their purest form at different temperatures. So first of all, you put it in the freezer and then you reduce the temperature to -2 degrees. In that stage, you'll be able to recover water, about 98% of water in the form of slush pulp. Then that ice pulp is recovered in the crystallizer. Thereafter, it's sent to the melting tank. And the energy that is then was taken off from the water by reducing it to -2 degrees is then sent back in the melting tank to melt the ice. And then we can recover water in the purest form. As we know, we have water challenges in South Africa. So one of the solutions that we are looking into is to be able to treat the wastewater which is generated. This is an emerging technology. It has never been done in the world. So like every day when I come to work, it's a new challenge because of what we're doing here. It must be perfect as it comes out of here, because of in the later stage, we are planning to then send this the technology and build them at different power stations where there are lots of wastewater which is generated. I enjoy my job a lot because of the best thing is that you can see something from an idea phase to the implementation phase, and hopefully up until it then sent to the station and then make a difference at the power station.
This is the Petroleum and Flow Sciences Laboratory of Eskom, and this is specifically the oil laboratory. When any transformer trips in the country, they're not allowed to actually put that transformer back onto process unless they send a sample to us. We must do a test. Within 5 hours, we must report the results. Because if they switch on that transformer, and the reason why it tripped is possibly due to a shortage, like it was arcing. Gas is produced, and if you switch it back on, that explosion can happen.
We do quality test, which is new oil before they are offloaded on the transformers. We do condition monitoring. We also do test the life remaining of the oil, the aging of the oil.
You can make a difference here which can affect the whole nation. You can have an input where it is needed the most, and you can use your knowledge and your skills and make that difference.
We are happy that the tests that we do, they can take decisions on that, which saves a lot on transformers for Eskom and to keep the lights on for the whole country.
This is the Eskom Rocheville 400 kilowatt PV plant, where we convert the sun's rays directly into electricity. This plant is serving two purposes. The first purpose is that it is increasing the energy efficiency of the building because it's providing power from renewable energy source. And the second reason is that it is built for research purposes. So Eskom gained a better understanding of how to operate, maintain and design plants by researching and doing investigation on this plant. This plant is one of the kind in the world because we have 9 different configurations, some facing east, west, north, south, and we research it and we analyze the plant in terms of performance to better help us in our future design and to train people and also to learn the operation and maintenance issues for future plants. Renewable energy, and particularly solar energy, is a new buzzword in power generation, and it's a new area for Eskom, and I am happy to be part of this new learning experience.
What we mainly do here is analyze coal, fly ash and clinker, as well as we've started to take on any particulate material. So recently we've also been doing a lot of work on steels, asbestos, soils, and any deposit you can find in and around a power station. Yeah, so this is our proud machine, so very proud of it. It's some of the most advanced scanning electron microscope technology available at the moment. And we are the only power utility in the world to be analyzing coal on it. Looking at an actual piece of coal, you'll see that there's a brighter section that looks like black glass and a dull portion. So your bright actually gets your fire started, your combustion started, and this sustains the combustion. So looking at the particulate matter, we can actually work out the ratio of bright to dull, so we can tell you how that coal is going to combust, how much of energy you're going to get out of it. Along with coal, let's say we have a certain mine that is delivering coal to us. They don't just deliver very clean, perfect pieces of coal like this. They also deliver a stone, if you can feel this. That's what we're paying for, but at the price of coal. So we've got to keep tabs, if you want, on suppliers to see if what they're providing to us is what they originally said that they're going to provide over the course of their contract. So how we prepare the samples is we usually get the samples as a PF sample, which is pulverized fuel. And then once this is combusted, you get fly ash. So we prepare blocks by taking a little bit of that powder and mixing it in wax. And after that, we polish it down to a really fine 3-micron finish, and we load it up into the instrument to be analyzed. I'll open up the instrument. That's the sound of the instrument venting. It's kept at a very high vacuum in order for the electron beam to be stable while it's analyzing the sample. So you also have to watch on the screen. We usually place the sample holder on a clean surface, like the new page of a book, and you put your samples in. So if you take a look on screen, these 2 oblong objects, they're the detectors that pick up the electrons. The screen is to ensure that the stage doesn't knock off the detectors because they sit pretty close. And then we put the samples under a vacuum. So now we just wait. The yellow and green colors. The green shows that the top of the column is kept at a vacuum, whereas the bottom chamber is orange because there's no vacuum in it. So once this turns green, we'll be safe to switch on the electron gun.
Barry, thanks very much for talking to us.
Tim, it's an absolute pleasure.
Much appreciated, and quite an impressive center that you have here, you know, conducting all the research, innovation, and some interesting things going on. Tell me a little bit about your center here.
Yeah, well, thank you, Tim. I'm glad you enjoyed your time there. It's been around since the early 80s, so it's about a 40-year-old building, but I hope you saw today that we've refurbished it several times over the years because Eskom values what it does. It's called the Eskom Research and Innovation Center, and really it's a mix of people with equipment and funding to do innovation and research work. So we've designed the work that we do around 18 centers of expertise. You can imagine in the power sector, some of the obvious ones are things like water and renewables and coal. But we're also looking at things like smart grids and energy efficiency and that sort of thing. So we have centers of specialization. I have a formula in my head that says if you take clever people, you mix them with good facilities, so you saw some of those today, you give them some direction in terms of what's important, and if you mix that together in the right sort of recipe, you get good work, you get good innovation.
Now, Barry, tell me about the research, testing and development. Does it all take place within the center?
Research, you get in research communities, you get scientific research, which is really trying to push the boundaries of science. And that's not really what we do, although sometimes we do touch on fortuitous innovation. It's more about applied research. It's about problem solving. Eskom has problems in various areas of its operations or in its long-term strategy. We inherit those problems, we internalize them, and we try and find solutions for them. The testing gives the scientists and the engineers results upon which they can make certain decisions. So if you want to, say, improve air quality, you need to measure the quality of the air. So that's the testing part. And then the development part is we often want to then demonstrate or pilot some kind of technology. So you apply a bit of capital funding, you create an asset, usually a small-scale asset. You then invite the rest of Eskom to come and have a look at what you've done and say, guys, if we do this on a large scale, in a power station or on a transmission line, we can solve your problem for you. So that would be the piloting and demonstration.
So would innovation then fall in there somewhere in development?
Absolutely. So this term innovation is something that people write books about to try and capture what is innovation. Innovation is not creativity. It's not just having new ideas. New ideas are easy. You go to bed at night, you have an idea. You wake up in the morning, you got another idea. The challenge with innovation is to apply the creativity, to take an idea and actually get it done, to get something done with it. So people who come to me and say, look, I'm full of good ideas, I say, well, that's probably half the journey. What are you going to do with your ideas? And they want to just dump them on people and say, well, that's someone else's problem to develop.
Now, we've spoken about the innovation, the entire ERC system, as you call it. All of your projects are within the sustainability division. And why were you placed under this division, you think?
So the sustainability division in Eskom exists to advise Eskom on sustainable issues like air quality, water use, energy efficiency, the mix, etc. And to do that, you need knowledge. In order to advise your organization on what to do sustainably, you need to understand how sustainable systems work and how they're put together.
Now tell me more about the kinds of people that you've recruited to work with you at this center. I mean, you've got a variety of talented and skilled people. Tell me more.
So we have quite a diverse group of people, when I say all, 90% plus highly qualified people. We're always pushing for further development and further studies. And then we have also technicians that work in laboratories and that sort of thing. So it's a broad spectrum. One of the challenges is to get that mix right. If you have too many people who are PhD'd, you sometimes struggle to get anything done because they always want to theorize about things. If you have too many people who might be technical and technicians in nature, they might be very busy but not really getting down to the nuts and bolts of the new innovation or the new creativity. So it's important to mix the right level of people and skills together.
And the work that comes out of the center must impact the Eskom operation somewhere. And are there specific areas and specific projects that the center has had an influence or impact on?
A dry cooling technique. You may or may not have been aware that part of the power generation process is the ability to heat things up very quickly at one end of the powertrain and to cool it down at the other end so that you get a flow of gases through the turbine. That cooling is done through cooling towers. Cooling towers generally use water. Now, in a dry cooling tower, you don't use water. It's a radiator effect like on your car, and so you reduce drastically the water consumption from power stations. So dry cooling would be an example of a technology that has come out of R&D.
But now, Barry, work does have an impact on us, depending on what kind of work you do, right? And at the same time, we also have things that matter to us as individuals in any work situation. Two parts to one question. What matters to you greatly, and what impact has your kind of work had on you personally as part of this big Eskom team?
Wow. What matters to me greatly, and why I've worked for Eskom for 25 years, is I like to see Eskom as part of the community. It's the biggest company in South Africa, and it has a direct impact on South Africa. GDP growth, poverty, electrification, energy, these things are the DNA of South Africa. So I'm working in a company that is directly attached to this country. And that means a lot to me. I actually have to sometimes remind myself of the impact that we had. The power shortages we had over the last 5 years, which are thankfully behind us, I think was actually, in a few years' time, we'll look back on it and say, it reminded us of how important we are to society and to the community. But at the end of the day, when I go home and I sit around the dinner table and talk to my friends about their jobs and I talk about my job, mine seems a lot more exciting, mine seems a lot more fulfilling, because I can say, hey, over the last 6 months we developed this thing that was applied in this part of Eskom, which has had a direct effect on the economy like this. It's great to see your work in action.
Well, very, very great and interesting stuff that you do here, and thanks again for your time.
Thank you, Tim. Pleasure talking to you.
As mentioned before, RT&D, Research, Testing and Development, is situated under ERIC, which we have learned a lot about from our Eskom experts. The RT&D section comprises of 5 different departments, and those are Technology, Strategy and Research Management, Plant Performance and Optimization, Sustainability, Power Delivery and Utilization, Business Enablement. RT&D's mandate is to conduct research, select and develop the next horizon technologies that support Eskom's future strategies and operational objectives. Research, Testing and Development further provides specialized technical testing and inspection services to the business, as well as technical consulting services aligned to their areas of competence. Finally, Research, Testing and Development develops next horizon technologies through robust pilot and demonstration project portfolios that highlight the benefits, the risks and steps required to implement identified innovative solutions. 18 centers have been established to concentrate efforts on critical environments. The teams are highly competent and are often consulted globally by other utilities. As mind-blowing as today's issue is, it is also a challenge to the youth of South Africa to also make a contribution in helping South Africa compete against advanced nations such as Japan, Germany, and others. We have also learned in our bit on Eskom's history about how old power stations as Hendrina have benefited from the research and innovation which led to sterling upgrades that are now globally recognized. I hope you enjoyed today's episode of Eskom's Journey. I invite you to join us again as we continue to make these amazing discoveries. Join us again next time. I'm Tim Modise. Goodbye.